Right, welcome everyone. It's Thursday, it's 3:32 to be exact. And I would like to welcome you to the first eBazaar from Things during the fall of 2020. It's great to have you all here. You might, if you've been here before, you might see that I'm not Magnus. Most of you know Magnus, and he's unfortunately away today. So I'll cover for him as best as I can. For those of you who don't know Things, it's a community, a network, a physical place that me and Magnus started together back in 2014. And since then we've been working with about 100 small, really sharp tech companies. And we currently have about 40 large corporates as members in our Things Enterprise Circle. And we're always open to more. So if you think this is a good thing, contact me or Magnus, and we'd be happy to have you as a part of our community. We're all about making sure that we get sustainable commercial agreements and business and having that developing between large corporates and small companies. We don't believe in that small companies will actually grow into huge corporations today. It's all about networking, making sure that you can have lasting relationships and good cooperation to make your company grow. We have 4 different focuses: industry, infrastructure, utilities, and mobility. So most of you who are listening today are probably somewhere in that area. We also work a lot with AI, ML, of course, like everyone does these days. We work with energy, automation and robotics, and different technical areas. So if you're looking for something in those areas, feel free to contact us because we have a really good network across the Swedish startup tech community. Currently, like I said, we have about 40 or 50 large corporates as members. Many of you are represented here today. This is the first eBazaar of the fall, and we have scheduled 4 another ones during the coming months. And in each occasion, we have a couple of different, we have one topic. So today we have smart factory. I think the next one is smart electrification, if I remember. And you will always find them on our event page. We will now also restart our physical events, what we call the Get on Top ofs. So as of Tuesday next week, we start having physical events again at Things. We're located on KTH in Stockholm. So if you're around, feel free to register and join us at these events. We'll have a Corona adapted format where we allow for maximum 30 to 40 people in the room. I know that we have more than Sweden online today. So in Sweden right now, we're allowed to have up to 50 people a meeting. If you want to join us on that one, the next one on Tuesday is on machine learning. We'd be happy to welcome you, especially if you're a tech member or a member at Things. Well, I think that's about it. We will still have a couple of people joining, I think, during the coming minutes. But I think we're pretty much ready to go. Today we have a great lineup of 5 companies that are all members of Things. We have first Martin from Sentian, we have Jan from Stream Analyze, Mattias from MTEK, Mikael from Unibap, and Rajet from Viking Analytics. They all have about 8 to 10 minutes to present what they're doing, how they can kind of give you a view on how that would fit well into your company. And then we have a couple of minutes for questions. I would like to ask all the speakers to put on their camera when they're speaking, so you get to see them. And I would like to ask all the attendees to ask questions. You can either write them publicly in the chat or directly to me in a private message. And if you are not used to Zoom, you can see in the bottom part there's a chat icon which you can use. Yeah, I think we're pretty much ready to go. During the spring, we did this 6 times. And by now we've had about 400 attendees from 25 countries. So talking to my colleagues Rebecca and Anna are online. Let's break that record, right? I think we have some really good results from the spring where we have some good contacts ongoing. I think that is it pretty much. We'll record the event. So startups and scale-ups, no secret stuff, you know. We put it all on YouTube afterwards. So you tell everyone what they want to know and you keep quiet about the rest that you take after the NDAs, right? Sit comfortably, grab a coffee and enjoy the ride. So Martin, you're first up. Are you ready to go?
Absolutely. Looking forward to it.
The scene is yours.
Thank you. I'll share my screen then. So will you let me know when it's visible to everyone?
Looking great. Yes.
Thank you. Right. So thank you very much. My name is Martin Rugfelt. I'm the CEO and founder of Sentian.ai. So who are we? We're a deep tech company doing a lot of stuff in reinforcement learning and optimization. And we say that we help companies with leading industrial AI solutions. And we always try to stay at the very forefront of technology to be able to deliver that competitive edge to our customers. And I'll tell you a little bit more about that claim to be a leader in this industry, and you will hear about that in the presentation. We have absolutely great customers. We've been getting a lot of awards and stuff like that. Last week, we made the New Techniques 33 list, which is very nice, and so on. But let me then talk a little bit about our products and our offering. We have 3 products: Icon, Intelligent Optimization, and Predictive Maintenance. And I'll touch upon all of them and have a case around Icon. But let's take a step back and just reflect on where we stand in the world. So if we look at the rate of progress, which is fairly fast, we can see that if you take between 1900 and 2000, we managed to squeeze in 100 years of progress. And that was a lot of progress, was a lot of things that happened. But it's interesting to see that things are going so much faster, that in the coming 14 years, from 2000 to 2014, we managed to squeeze in another 100 years of progress. And we're right on time for squeezing in yet another 100 years of progress in only 7 years right now. So I think there is a reasonably interesting question to ask of everybody. Where will you be in 7 years' time? And if we take an AI perspective on this, AI is now seeping into all solutions and all areas of all businesses. And there's a lot of things going on. If you take the amount of development that's made in the AI community in the US or in China. China is, by the way, one of the countries where most of these new patents in AI are being created. So it's really interesting to see how the technology is evolving. And if you want to be at the forefront, you better get on the train and go with it. So the theme today is smart industry and industry 4.0. And for us, industry 4.0 is really about speed and efficiency. So how does that stack up for the industry today? Well, if you look at incumbent automation and control systems, there are some challenges. The industry is really a high dimensional place, which is non-linear, it's stochastic in its nature. There's a lot of these situations where the existing and incumbent solutions are not that. They're linear solutions, or they're not very adaptive in general. They're reactive instead of proactive and so on. And there's a lot of different challenges that these systems are working with. Variations in input parameters, deviations in production quality and high scrap levels, speed versus quality trade-offs, dependency on expert machine operators, these people that really know their stuff. And that means that there are a lot of challenges that are hard for these systems to really manage. So what we've done is we've created Icon. It is a solution that makes these industrial control solutions more adaptive to changing environments. They can tackle more complex processes, and the industry is going more towards more complexity and more flexibility all the time. So it is a challenging environment, and also combining the human and the machine elements here. This technology is based on our scalable solution in reinforcement learning. And reinforcement learning is quite interesting because it's a technology that has been talked a lot about, but has been very hard to harness its power. Google did with their AlphaZero products that beat the world champions in Go and so on, but we haven't seen many solutions in the industry so far. But this is what we've done, and it really works fantastically well in terms of scalability and performance. What we really have is a solution that meets all of these problems. So it's fast and robust, it's dynamic and more accurate, it's proactive and non-linear, it's scalable. And if you compare it to building your own solution, it's a lot faster to implement, and we have this continuous development of this process. So really much more efficient than these analytical solutions. So what do we use it for? Well, it's things like maximizing yield, reduce cost of production, increase autonomy of your machines and systems, and use expertise in a more optimal way. So you can capture that knowledge from your experts and make it available, for instance. And it's applicable to many areas of the industry, from making robots move more optimally to optimize production cells, integrate digital twins and so on. It's possible to use it for complete plant operations. So if you have like a power plant and want to run that more optimally or so, you can use this kind of technology. And machine calibration, anything from making them work a little bit better on a digital level, but also learning from expert operators and maybe enhance junior operators, for example. The typical improvements is for up to 30%, so it's quite important. You can really use it for gaining an advantage. I also want to talk to you about our second product, our intelligent optimization solutions. Again, there's a technical breakthrough here. At the end of 2019, we made a technical breakthrough where we broke the current world record for nonlinear optimization in the QAP category. So quite an interesting thing that we did on this side. And in fact, it's the more complex, the more of a difference to the competition there is. So it's really powerful. And we use this for things like planning optimization, whether it's people planning or production planning, where it's supply chain optimization or logistics optimizations. So lots of opportunity. And there again, it's up to about 30% improvements that we can find there. We also do predictive maintenance, and it's not only about then having a suite of algorithms that can handle predictions and anomaly detection for factory floor or distributed environments, but also integrating the two former products that I just mentioned, like making sure that you have automated settings and calibration, or that you optimize the allocation of resources to the maintenance task, making sure they are at the right place at the right time. Right, I also wanted to take the opportunity to tell you about a case. So in this case, it's a company called Unibap, that's a leading sensor and automation company. Their strategic goal was obviously to reduce cost and add revenues when they wanted to do something in this space. And what we did, sorry, that was two. The problem they had was that they had this manufacturing process where there was a small but significant process variation. And they wanted to see if they can add AI to their automation control system to be able to improve the sensor accuracy and overall yield of production. They had quite a bit of challenges, not much data, variation that drifted over time. There were different sources of variation and lag time of several weeks for the feedback loops and so on. So lots of issues. And having implemented this, we could increase the quality of their products with 20%. So it's a very significant improvement. It now handles these updates to the system automatically, and we've applied it to lots of different sensors. So this is really what we would be talking about, enterprise AI at scale, so across the board of that company. It's applicable to not only manufacturing, but also oil and gas, automotive, utilities, paper mills, pharmaceuticals, chemicals, mining, all of these industrial areas. So lots of potential for implementation. So how difficult is it? Well, the core need for being able to do something with this is that you have a challenge, obviously, that you want to look at improving, and you have to have some data. But it's interesting that it works from small data to large data. And you can also apply the system from weeks to a few months. So it's not like these take 2 years or anything like that to implement. So lots of potential. Finishing off by just saying that if you have a challenge, please get in touch. We're happy to discuss it with you. You can also say that we just released a white paper with our partner Device Insight. It's downloadable on our webpage, and it's all about AI and IoT combined, what we call AIoT. Right, thank you very much. Please let me know if you have any questions.
Brilliant, Martin, as always. So let's see, do we have any question from the audience? No, not yet.
Yes.
A minute.
Well, if you do want to get in touch with me, my contact details are on the screen. And as mentioned, I'd be very happy to discuss this kind of technologies and our products and how you can apply AI, well, pretty much across the board, from predictive maintenance and anomaly detection to make your machines available, to optimizing the production and your machines, to optimizing supply chain and logistics and these kind of things.
Brilliant. All right.
In that case,
no questions yet for you, Martin. I think it's all very clear.
Very good. All right. Thank you very much.
So do get in touch with Martin if you want to talk more. Next up is Jan from Stream Analyze. Jan, are you with us?
I am. I'm here.
Brilliant.
Take
it away, Jan.
Great. So let me share my screen with you. So Stream Analyze, we develop software, tools and systems for interactive real-time edge analytics. And with edge, we mean small devices with limited memory capacity and CPU capacity on the edge of a network, maybe not always connected, but connected sometimes. And with real time, we mean that the sensors, one or many that are connected to these devices, they produce data in real time, and this data is being analyzed in real time. It's not any analysis being made on batches of data. And the type of analysis that is being done are everything from simple mathematical statistical models to machine learning and deep learning models. All those tools are included in the platform. And with interactive, we mean that you should be able to interactively change models, deploy new models, revoke models, but also drill down on the machines that are connected either in your factory or remotely in the field to understand what an anomaly what the root cause of an anomaly might be. So I will share one case with you here. It's a machine manufacturer working together with you can say a financial institution, and they wanted to understand first if there are technical anomalies appearing on their machines, but then also how are these machines how are they worn down as they are being used, because this plays an important role for the financial institution leasing these machines to the customer. They want to know if what is the residual value of the machine, because if the customer doesn't pay the bills, they have to claw back the machine, and the value of the machine might be very different from the value in the books. So in this case, what is being done is that the model, you can say the cyber physical model, is being deployed on the machine, and on top of that, you have a financial model also being deployed on the machine, and the financial analysis is being done on the machines itself. And then on top of this, we also have how you communicate with the system, and that communication is being done through existing software. So you can do it through Excel, or you can do it through our existing ERP system. The purpose here is that it should be easy for the staff, existing staff, to do this, create these models, so they can develop these cyber physical models and financial models without having to use external resources. They can do that with the tools in the platform. If they are built models using other systems like Google TensorFlow or so, those can be plugged in and reused. How is this being done then? Well, you start out with a cyber physical model running on this edge device, and this model might analyze something like, let's say, vibrations. Vibrations might be the root cause for wear and tear on this machine, and you use that as the basis for your financial model, which you also deploy on this edge device. Then, of course, you have a price list that is targeted to these costs that are being accrued on the machine, and those can be controlled from an existing software, like, for instance, Excel or SAP. So you push them out onto the machine, the fleet of the machines, and those costs are being calculated in real time and then pushed back to the software being used in this case. This means that you can address a number of different use cases here. You can have dynamic leasing as the use case I just showed you. You can have machines, let's say, order spare parts and support on their own. Of course, you can sell products as a service and so on. So there are many different use cases you are able to implement here. What are uniqueness here? Well, let me start with these 6 ones here. We have a very small footprint, meaning that you can fit onto existing hardware. You don't have to invest into new expensive hardware or design that hardware onto the machine. You can change the models and the algorithms running on the machines, everything from simple price lists to very analytical models on the fly interactively. But you can also drill down on the machines to get a better understanding of anomalies appearing. In this case, it's based upon a high-level query language, which makes it easy for the domain experts, engineers, analysts, etc., to understand how they can build upon their existing knowledge without having to recruit 5-star programmers to implement this. And of course, you can implement any kind of model, everything from simple mathematical statistical models to deep learning models. So this is it.
You're fast, Jan.
Yes, I am.
So let's where would you? I don't have any questions yet from the audience. Where would you say the strongest business case for what industry or what application?
I mean, we work with a number of industries. We work with automotive, we work with utilities, and we also work with manufacturing industry. And we see many of these trends happening in many of these industries. They might be different. I mean, if you look at the automotive industry, we're working closely with companies doing autonomous drive and similar systems. If you look at the machine manufacturers, they would like to move from selling machines to selling services and services instead. And then, of course, these financial applications, doing financial modeling directly on the machine is of great importance to understand wear and tear and how you can charge differently for the machine, maybe based upon usage, etc.
Would that be able to use down to, I mean, individual products you can actually
you can do it on an individual machine as well as on a fleet of machines. So you can do it. You do it not on a fleet basis. You do it individually, but you collect the information on a fleet of machines, so you can manage a large number of machines simultaneously, of course.
Brilliant. All right. Yes, now I got a question here. How can these applications be built so they're human-centric and not machine-centric?
Yeah, they are. I mean, the algorithms are being built by humans. The machines doesn't build the models themselves, but so you have your existing engineers, analysts, data scientists. The ones with domain knowledge, they can easily implement these models themselves and push them out onto the machines. So I would say that yes, that's human-centric, and then of course the machines themselves, they run it without having any. You don't need a man in the loop to do the real-time analysis. That is being done as the machines are running out there. You only need to interact when something goes wrong, when there is an edge case appearing.
Brilliant. All right. I think that's it for now. In case you have questions and you don't, I mean, you're not on your feet when the speaker is done, feel free to ask them afterwards, and then please direct them to the company that you're targeting. Then we can pick up questions also afterwards.
Thank you.
Thanks a lot, John. So third speaker today is Mattias. I can see that you're ready, Mattias, from MTEK.
Hi all.
Hit the scene.
I will share my screen. Start my presentation. So thank you all thanks for giving the opportunity to present. So today is actually the launch date of our system Membrane, which is, for those of you that have met us before, you've seen a lot of things regarding robotics and how to program robots and make sure that your certain applications on your manufacturing floor is simplified through adaptive automation. What I'll show you today is parts of Membrane, and we'll go through a little bit about the launch, and I'll be happy to give you guys a personalized demo whenever needed. So MTEK, what we're all about is trying to make manufacturing simple. I'm the CEO, founder of MTEK, Mattias Andersson. So looking through the manufacturing complexity, every manufacturers are unique. Everyone strives with the same problem, that they have information, different silos. They're running a lot of different systems on the shop floor. Maybe the interactions of all the employees within organizations to the data, process data and production data, maybe it's not as good as it should. And this is something that we would like to address and be part of solving. So today is actually the official launch date of Membrane, our factory intelligence system that allows to connect to any machine on the shop floor, provide value through analytics, as well as manufacturing order handling, Ichikawa, Kaizen or continuous improvement tools built in, risk analysis, and also making sure that production flows easy and is visualized, and of course with complete track and trace. So basically, I'm going to introduce you to Pete. With that said, moving on to the next page, hopefully now. Looking through value creation on data that lies in silos on the factory floor. We've been looking through an organizational different needs and looking through anything from the engineering perspective or the quality engineer's perspective or the production manager's perspective or the logistics manager perspective. Everyone relies on value creation throughout the manufacturing floor. So this is something that we addresses. So if you have today on the factory, you have different system for quality follow-ups, you have different Excel sheets for planning, we can actually address that and combine that into one system. So, of course, providing the full track and trace, so you can get, in the end, a personalized experience for the products that you build with a complete log of all the activities that actually happen on the shop floor. So we have a solution that is extremely modular. You don't need to take it all. You can join just with the connectivity part for the machines and the planning parts, or the advanced analytics part, or the flow builder. We also have the capability for within the software to create your own standard operating procedures that allows you to actually deploy work instructions by a push of a button. We call it push button transfer. So looking through the M-Range approach, you would say, well, that's why would the world need another MES system or manufacturing execution system? Well, the world doesn't. The world needs a system that actually can create value over time and allows the user to create value using those different functions and modules. And once again, it's completely modular. First, of course, you look through automation with the cost of creating a business case for direct labor. But we believe that putting the humans first and allowing the humans to interact with the system, and then creating further analytics in a simplified way, you can actually have the factory staff, just as Stream Analyze pointed out, to make sure you don't need to have highly educated engineers to create data models for neural networks. You can do that inside our systems as well. So with that, it's a fairly short presentation, but I'll be happy to answer any questions or provide a personalized demo for you and go through the features and functions of M-Brain. And once again, M-Brain supports the product's lifecycle. It's not just about manufacturing, it's also preparation. We have design modules, and we have end-of-life features in it as well. Thank you.
Thanks a lot, Mattias. So everyone, feel free to ask questions. In the meanwhile, Mattias, I know of some activities that you've been doing with one of our companies, for instance.
Yes.
I'm not mentioning names because I'm not sure what's public or not. So why would you say that that was such a kind of happy marriage?
As a happy marriage, I believe the purpose that we're doing is to augment the humans, making sure that people has the right information at the right point in time, making sure that people are given the capabilities to do the right things. And not only that, but also automation being one part of it, but everything boils down to making sure that the information is shared and everyone is working with the same data. To remove the guesswork out of improvements is extremely important. So the collaboration has been really good, thanks to things, and we're now scaling up with them, covering their entire operations. So it's really looking forward to the journey that we're on with that client as well.
And when you met with this company the first time, what was their, was their problem the same as the problem that you're currently solving? I mean, what was the reason for you to meet up with them?
First of all, when we started meeting with them, the initial discussions were regarding automation. So that's how we started. And that has led us to digitizing their entire manufacturing. Automation and digitalization goes very close. And looking through, the first thing that we did was actually giving the order and planning department the capability to get real-time visibility on the shop floor. And that is then involved into further instructions creations. We can shorten the lead time. We can help improve the quality, all driven through digitalization. So digitalization means people, making sure people are onboarded. You can say that M-Brain provides the transformation tools for the digitalization journey.
Mm. Which probably applies to most companies out there, I'd say, today. Thanks a lot, Mattias. Our fourth speaker today is Mikael, one of our newest members of things, I'd say. Welcome, Mikael. Take it away.
I will. Let me see if I... So, does this look okay? See my screen?
Looks okay, Mikael.
Perfect. Okay. Hi, everyone. My name is Mikael Steiner. I'm responsible for sales and project execution at Unibap. So I'm going to tell you a little bit about our company and hope to give you some inspiration of what can be achieved with applied machine learning for industry. So we actually are working with several things within Unibap, but today I'm going to focus on our business area for smart industry. So what is that? We make what we call intelligent automation solutions, and it's pretty simple. We combined vision with dynamic robotics and AI machine learning. What we're trying to achieve is to create abilities to mimic human behavior. Typically, what we can achieve is quality inspection. That is to automate assessment of a certain feature of an article. System can learn to recognize a fault unit from a defect unit. It can classify different defects and deviations. But it's not only on the surface. We can also check the entire form factor and see whether it's matching according to specification. Is it also a complex article? Let's say it's assembled. Is it assembled correctly? Have you put in all the contacts or pins in the right direction? Or let's say a medical syringe, is it filled up properly? Everything is pretty easy to achieve with artificial intelligence. What we heard earlier, like there's a lot of open source algorithm, and our knowledge and experience so far is rather easy to achieve this in the lab environment with perfect conditions. The hard part is the reality when we do it empirically in a production line at a customer facility. But there are also more things that we can do without hard coding a robot or a vision interface, such as identification. Is it the correct article coming down the line here, or the position of an article if you have a dynamic system to pinpoint a robot gripper to a moving target? If we want to pick things, we can combine it with an aerial camera that makes an initial quality assessment, position the detail, and we're also picking it. And we're picking details down to 2.5 millimeters at the same time we do this quality assessment. So that's really interesting to see when we combine these different abilities in one and the same system. You get really powerful functionality. Reading also here is not rocket science for AI, but it's a neat feature to add if you already have this kind of setup. Let's say you have a casted number or a stanced or printed that is not really well printed. It can be hard for the human eye to see, but for an AI algorithm, it's really easy to see even a damaged letter and so forth. So everything in together, you can make really powerful artificial operators. So how is it installed? We use fixed mounting systems. We could just hook it up to your production line. We had a vision system, we had lights, try to seal it off a little bit. But when it most comes to life is when we combine it with robotics. Because if you mount the vision system on a robotic solution, we can guide the robot to check and hover around a certain article to even a complex article we could see from several different angles. Another alternative is to let the robot grip the part and show it to a fixed camera. And this is interesting. Let's say in the case you already have a production cell, you might have the robot gripper and everything around it, and you have a few seconds cycle time left. Why not use that for quality assessment? And also when it comes to a full robot cell, why not let this cell do more than it already does? So really powerful solution, extremely flexible. If we have really difficult systems or issues to solve, we prefer enclosed vision boxes, like in cabinet, we have absolutely no additional variables to take care of. And these could be robot fed or manually fed. So really interesting results can be achieved out of this. So this is a principal view of how it works. Regardless whether it's a robot cell or fixed vision, we communicate with a PLC or a production system, get notified. What is it? Our AI in the middle assesses the object and do all checks that we need to do on it. And a fraction of a second later, we communicate with an offloading system. It could be manual. So the operator sees, well, don't touch that. That's a faulty unit. Or we communicate with an automatic offloading cell. But I would like to highlight here that matches really well into the previous speaker is we can also be a data provider for plant MES systems such as Membrane or a quality system and provide it with data. And usually today quality assessment is made manual by human labor, or you do samples of a full batch. We check each and every produced unit. And it's actually when you start to measure everything that we can measure true quality. And to our knowledge, most customers that we work with have actually seen that their real quality might not live up to their expectations. And when you know your real bottlenecks or issues and how often they occur, you can start to pinpoint the root cause of it. And the ultimate goal with this is to have fewer defects to reach the end customers or further down the line for further processing in that plant. Everything is saved, you get a full statistics. So we do not do the analytics ourselves, but we are a data provider for an analytics system. And since most of discrete manufacturing quality controls, at least the advanced controls, are made manual, this is a great way of reducing boring, monotonous, and potentially work hazards too. See for yourself, if you're turning and twisting a 5-kilo cogwheel to see all the details, it will wear out your joints in the arms. And this also enabling operators and plant staff to be focusing to more value creating tasks. And also higher production pace. So let's look on our real-time artificial operator in use with a high volume production. This is a system that make real-time live decisions, communicate with a fully automatic offloading cell. We're assessing about 2.5 million articles a year. And the proven facts of this is that we now produce way less quality defects, or at least it doesn't reach the further assembly down the line, and it enabled a higher product pace. Not to mention that this system actually, I think, occupied about 7 people with offloading and the quality assessment. So these operators now can perform different tasks in the plant. So let's look into it. What is it that we actually can find? Let's say you have an industrial paint shop. Let's identify what's coming up. On the surface inspection, we can see rinning, drops, blisters, scratches, unpolished areas. We categorize them, save the results. We can also do a form inspection directly from the foundry. How does the cast look like? Is it correct? Is there any missing material? This is of course applicable on all kind of machine components. This could be automotive parts, an undercarriage for a truck. All critical components with a high degree of machining before. Is it threads? Have you drilled through? Is the hole positioned correctly? Are there micro scratches? Are there chips? Cracks in the material? And at the same time, we do a form inspection. I mean, we could check the details and also edges and corners, really enable you to know that the defects are left in the scrap bin instead of reaching further production. Welds, another useful area where it's really popping the errors. And also very interesting to combine with robotics. Let's preload the CAD shape of the object that you're assessing, and the robot could follow all the joints and automatically do an assessment of it. Finally, I also like to see this is not just applicable for machined metal and electronics parts. AI doesn't hook to fixed edges. It's excellent for biological or uneven surfaces, complex surfaces. So in this case, we work with somatic embryos, doing a fully automized picking and quality assessment, removes manual planting labor, lowers production cost, and we actually take one for the environment. We're increasing replanting all over the world. So to sum it all up, this kind of system can be used as an autonomous operator, an artificial operator, and it can also use an operator support system if you have a slower process. Let's have the system notify the operator of, hey, here I actually think that you have a defect, and the operator have the final say whether it's a defect or not and can approve it or not. So this is what we do. And if you want to learn more things about this, don't hesitate to go to our web, www.unibap.com, or check us in on LinkedIn or Twitter, or contact me personally. I will be thrilled to do your acquaintance. So thank you, and let's open up for questions.
Thank you very much, Michael. So you've got a question here.
Okay.
What is the biggest challenge when implementing smart factories with AI learning?
when it comes to AI, I mean, what differs AI training from traditional training and programming from a robot cell is that we need samples. We need samples to train from. So early on, we had issues with finding defects, because we needed to train on defects, and a good production facility didn't produce that many defects, so it could take time, and that was a great challenge. Now we also train a lot on complete or correct units. That has been a great improvement for training the system, have it pre-trained before. But I would say that is one of the biggest challenges. The second biggest challenging is the reality. See, back in the lab, you have perfect light conditions, you don't have any vibrations, you don't have everyone messing with your stuff. Out in the reality, everything happens. I just say we've seen it all. That is a big thing. You need to have a super accurate algorithm doing 24/7 work in very harsh environments, and that is really the key to make it work, I'd say.
You mentioned samples there. What is like a minimal sample size you think would be reasonable to draw conclusions from?
Let's say you have a fairly complex unit. That is a pretty high degree of variation on the surface. I'd say, like, to train it with a couple of 500 correct units and then as many errors as possible. Let's say 50 errors, we could have a really accurate algorithm. But I mean, sometimes it doesn't help to do more training, but in generally, the more varied training that you get with different defects usually helps the algorithm a lot.
Great. We got another question for you here.
Okay.
Can Unibap system adapt to more specialist manufacturing, so lower quantity but higher quality manufacturing?
Sorry, I didn't apprehend the first part. Could you repeat?
Can Unibap's system adapt to more specialist manufacturing, so lower quantity but higher quality manufacturing, where speed might not be as much of a concern as the precision of the end product?
I'd say low volume is always an issue. Because, I mean, if you have low volume, you usually have more value in each product and you have more time to do a manual assessment of it. So typically, I'd say this would not work as well with low volume, extreme flexible production. This is more a high volume, complex article kind of fit. But I won't say never. I mean, it depends all of what the customer is prepared to invest and how complex of a problem it is. I mean, let's say a perfect pattern, that could be required a very little training and it could be super accurate. But a die casted point of aluminum with a very rough surface in which you anyhow need to find small cracks in a vibrating environment, that would definitely require a high degree of training.
Would you be able to do it?
We are, at this point, have been able to complete most challenges that we've been put in front of. But we only accept the really tough problems at this time too. It's a lot of what Vision can do with the simple solution that we provide. But it's great fun.
Mm-hmm. Well done, Michael. Thanks a lot.
Thank you.
Then we're ready for our last presenter. It's Rajet from Viking Analytics. Are you with us, Rajet?
Can you hear me and can you see me?
Yes, absolutely. Take it away and share your stuff.
Yeah, let's do this. Can you see my screen?
Yes, absolutely.
Okay. First of all, Linda, thanks for having me here, and good afternoon to all of you in this talk. I know it's towards the end of the day, but I'll try my best to keep you awake and alive till the end of my presentation. So we started at Viking Analytics. We started our journey in 2017 with this really exciting consulting project that we had with AkzoNobel in Netherlands. It was primarily a task where we had to predict the health condition of their electrolyzers in a plant. And based on the health conditions that has been predicted, we had to distribute or optimize the energy distribution. across, or the electricity or the energy consumed by the different electrolyzers. At the same time, we also had to do predictions of the pricing in the energy market and decide on how much of production had to be done. So it was an extremely complex problem that we had to solve, and not just in terms of prediction, but also sending set points back into the plant, right? And after 3 years, today, as it stands today, if you go to Rotterdam in Netherlands, some parts of the year, this plant is entirely run on our algorithms. And this was really the start of our smart factory journey. And what did we learn from this? What we learned is that building smart applications for the smart factory, like predictive maintenance or control or optimization, in a scalable, reliable way, is extremely challenging, especially if the domain experts, the people who are in the plant, their knowledge are not integrated into the solutions. This is because we realized that many of these domain experts have to analyze the data, they have to understand the data in order to contribute to such solutions in the first place. So we realized that these domain experts who are not necessarily data scientists can spend a lot of time cleaning the data, preparing the data, analyzing it, annotating it, or describing the data to an algorithm and getting to their insights. And once they have their insights, deploying algorithms based on the insights was another super hard challenge, and troubleshooting it and monitoring it and maintaining it was another complex activity. And what we started realizing is that there would be several millions of euros of losses in terms of opportunity cost, several man months and weeks of man hours lost because of the complexity of big data analysis and deployment of solutions. And this is how we started building on our product called Multivis. And how does Multivis help smart factory solutions and smart manufacturing? Multivis helps organizations and their domain experts to start all the way from raw data, raw sensor data, helps them to explore it, analyze it, annotate it, describe it in some sense, and then get to insights very efficiently and quickly. And once they have the insights, we have a deployment tool which helps to operationalize these insights as smart applications. On top of that, many of these machine learning based applications require continuous testing and verification and debugging, where typically an expert may also be involved, because debugging such applications involves debugging the data as well, and enabling them in this full journey of starting from raw data to an application and testing the application is really what our tool is capable of doing. So today, Multivis is, as we call it, a self-service platform. It's not completely self-service in the sense today a completely SaaS solution yet, because we are still early stages of development, which means that we work with our customers with the tools that we have, but the vision is to go fully SaaS with minimal support from our side. But today, it's a bit of a different story. But enabling them to visualize the data, prepare the data, analyze and annotate, describe the data, and once we have the insights, and we start the organizations and their domain experts build models, deploy models, and maintain them. This is the full journey we enable our customers to perform. And there are multitude of applications that we work with, including root cause analysis, scrap analysis, machine learning deployment, predictive maintenance, predictive quality control. And one aspect that really makes us stand apart from many other solutions out there in the market is using this platform, using the software platform. Many of the domain experts are able to build expert-specific applications themselves, maybe for vibrations, maybe for valves, additive manufacturing, so on and so forth, which they can build and also deploy. So, because of the solution that we have in hand, because of the platform that we have in hand, we are able to support extremely complex deployments, extremely complex smart factory implementation. One example here is from Schaeffler, a big company, a customer of ours who wanted to implement proactive and predictive maintenance for from millions of data points from thousands of machines across the world. And they used our tools to annotate the data, to describe the data, and build solutions for minor stoppages, anomaly detection, predictive maintenance, for predicting health trends of their assets, so on and so forth. And they were able to use our tools to not just build solutions for one site, but they were able to build, generalize the applications for multiple sites and for multiple assets. Right. So now this solution has been deployed in at least a few tens of plants, and the ambition is to go into a few hundreds of them by the end of next year. Another example that I can tell you is from the context of metal pouring in foundries, where our tools were used for deploying a smart operator which would operate the metal pouring instrumentation purely without any human intervention. And with that solution, this solution has been now rolled out in at least 3 foundries. By the end of this year, we anticipate that the solution will be rolled out to at least 15 foundries. So just empowering, putting the power of data into the hands of folks who actually understand it can truly transform the industry. And this is exactly what we are seeing. And this is what we believe in. And this is why we are seeing this tremendous form of traction, even during these extremely difficult COVID times, because we enable experts who understand the data to actually transform it and commercialize it into an application at scale. Right, being able to build industrial solutions at scale, with our help, with the help of their in-house data scientists. So we have about 16 customers today, and our customer group is definitely increasing, and we are seeing a lot of traction in the market. So this is what we do, and I'd be happy to answer any questions that you may have. Thank you.
Thank you very much, Rajet. Let's see. So I think I'll unshare you.
Yeah, I can.
Otherwise, I saw it myself, I think.
Yeah, so there you go.
Okay. All right. So let's see. Do we have any questions for Rajet? Yes, I got one here. I'll read it out loud as well. The question on everyone's mind around the globe has been that AI will take over jobs. Question for all companies. What are your predictions that by implementing these applications in industrial settings, there will be reduction in workforce? I think that's, yeah, so it's actually for all the speakers. Feel free to pitch in.
Maybe I can just throw in my 2 cents here. For sure, there will be, just like jobs become automated, there will be many jobs that are automated. But that said, there's so much of domain knowledge that sits in the brain and the heads of so many experts around the world that that's almost irreplaceable given the technologies that we have today. But yes, there will be automation at multiple fronts in many ways, for sure.
Anyone else wants to pitch in?
Mikael here. I mean, this was also said about industrial robots 30 years ago. So I guess this is natural progress. And that's the way that we can compete with production facilities in Western countries, a high degree of automation and autonomous processes, I think. So it's, yes, but unqualified labor will be tougher to compete with, definitely.
And this is Martin. I guess the underlying question here is not that we will automate more. The question is if we will keep up with creating new jobs when we automate existing ones. And that may be tough. On the other hand, there's always new niches that come up all the time that are beyond what we do in the industry. And these movements in the marketplace or in the market is probably what's going to add new jobs in the world. Question is if we do that enough. If not, we may have to go from having a 5-day work week to 4-day work week, which might not be so bad.
Sounds pretty good to me. Mattias, Mikael, or Jan, do you want to, or Mikael?
Yeah, sure. No, looking through AI and automation, I think there's a direct correlation actually with companies that decides to automate actually tend to over time employ more people because they become more competitive. And the same thing goes with AI. Now AI is a huge buzzword and there's a lot of applications that, like the ones that we've seen today, provides great value. But I do believe that contextualized AI, where you can actually get better decision support, is where we're heading. And everyone strives to do the right thing and do good things, first of all. And if we can get AI to help us take better decisions, will lead to better, to become more competitive. So I think to an extent of having those lights out factories and those completely autonomous AI with unsupervised learning, well, lights out factories they will become a reality, but not in the next 5 to 10 years. AI to take over the world. Let's start with ordinary intelligence first.
No, I agree fully. I agree. I think it will not be fewer jobs. There will be more jobs. It's just that the jobs will be different, and we will see people have to change maybe some of the work they are doing. But there will definitely not be fewer jobs in the long run. Definitely not.
Great. We actually got a question for Unibap earlier that I missed. So for you, Mikael, how far off, it's kind of linked to the other ones as well, how far off are we of having AI robots in our factories? When will your product be sold in larger scale?
It's a different, I could say it's a great deal of skepticism among the industry, and the high degree of precision for an initial system is that's a factor. Not everyone dares to try an evolving product that is immature and be the spearhead. And we are really thankful to have Husqvarna as test bed to really prove that these things work. And I think after a few pilot installations more to prove the concept, I think the interest will be greater and greater. But I say we also need to find new procurement methods, because just as you are a new employee, like your first day at work, you're not expected to perform as you do after 10 years. And that's the same with an AI system. It gets better with time. And that's a unique difference too. If people accept that the system will evolve over time, it will definitely be a door opener for large scale operation.
I've also got a question for all of you guys. What challenge are you still waiting to hear from a customer where you see that your different applications have amazing potential? Where has the customer not yet woken up?
Martin, I think that you see that there are innovators that are trying out the most advanced ones, but at the same time there's a huge amount of laggards that haven't even gotten started yet, and may even be in the stage of collecting data and not getting further than that. Then the next natural step is for all of these companies to do their POCs, and then eventually they realize that they need to scale this, and they'll have the discussion around, is this a build or a buy, etc. And it's a natural evolution, but I think you can see from all of these kind of things available in the market, from the spearhead new technology implementation all the way down to, yeah, let's get started on the use cases.
I would probably add regulation, that there might be a lot of regulation coming very soon from EU and other parties that might, let's say, create obstacles and hurdles, not only for smaller companies, but also for larger companies wanting to implement different types of AI solutions. How the information is being handled, how it's being processed, where it's being processed, etc. And I think it's important to keep an eye on that and to be on top of these regulations, so you don't, so everyone tries to, let's say, influence and tell the regulators what kind of possibilities there are and how they will be impacted by these regulations going forward.
Adding to the, oh, sorry, can I just pitch in my thoughts here? Rajet here. So I think both, in addition to regulation and also the laggards and the early adopters, even I think we are at such early days of industrial, digitalization that many of the tracks that we have taken, even for that matter, even the ones who have woken up, they are extremely early stages. We still haven't really understood how to monetize and at scale, right? I mean, there are POCs that are great, there are activities that are really profitable, but really showing it's a huge effort going forward, and unless there is this. Unless there is a multitude of the industries actually wake up and experiment in different ways, we are really not going to find, okay, this is the way to do it in the best possible way, right? So it's really early days, truth to be told, and I would say most of the industry has woken up, but they are like behind the AI hype, which they really have to get out of to actually start seeing the true value. So there's more than waking up here, which is the bigger problem. That is moving out of the hype more than anything else.
I can imagine that a lot of companies are still in the early days. I mean, you guys are kind of the spearhead in this area. So of course, everything that's like everyday stuff to you, that's still on the factory floor. It's still amazing. How far should they have come when they start contacting you? Do they have to have a clear idea on what they want to solve and how they want to solve it? Or can they just like, hey guys, this is what I have, what can I do, kind of thing?
Well, if I may answer that, I think we probably all the other ones too, but happy to take on companies depending on obviously situation from start to finish. That's a natural thing to do in AI today, as Rajet just mentioned, it's very much immaturity here, and you have to help companies along the path in many cases. Though it's obviously ideal when people have lots of data and a clearly defined problem.
Yeah, but I think just to add to that, I think many of the companies who are pitching here today, I'm pretty sure that we all would be in a position to help companies also identify low-hanging fruits, yeah, because that's really another challenge that the industry is facing. I mean, they have formed digitalization groups, they have digitalization efforts, but what are those low-hanging fruits? Where do we start? Where is it that they can ask for a bigger budget? And these are things that I think many of us are helping bigger companies as well, and we'd be and of course this is something they would be able to do it themselves. But of course, with partnerships, there is the good thing about many of us who are pitching here today is that we have this cumulative experience of having worked with multiple customers, that we are able to give them a guiding force right from the beginning of the journey itself. So that's the other thing to pitch here on the behalf of everybody pitching here. Sorry to.
And to complement that, I find that it's not uncommon that we, as experts, help them find things that they had no idea was possible. And the challenge, I think, for most companies to be honest about their own problems and pain points, and daring to express them, not assuming that it can't be solved. Because in many cases it can, it's just they haven't thought about it. That's happened more than once.
Thanks a lot.
Right.
I don't see any more questions from the audience. I would like to just wrap this up for today then. In case you missed any of the presentations today, like I said, we have recorded everything and we'll put it up on our YouTube channel in a few days. After this event, you'll get all attendees will get an email with the contact details for all our speakers, contact details for me and Magnus at Things, and also a link to a super short survey. It's like 3 questions or something. So please respond to that one, because that gives us great input on what is good and what can be better. I would also like to just throw out there our upcoming events. So in this format, the eBazaar format that we have at Things, we have the next one on smart transportation on October 8th. Smart electrification on October 29th. We have a lot of smart stuff now, to be honest. Smart buildings on November 12th, and smart mobility on November 26th. So in a couple of days or a week or so, they will all be up on our webpage, thingsstockholm.com/events. And like I mentioned in the beginning briefly, we will also restart having physical events in Stockholm at our place at KTH. So if you're in Stockholm or in Sweden, do give us a shout out. We'll have machine learning on Tuesday next week, which also gives people a great opportunity to actually, again, meet new people physically on a COVID safe distance. We'll have 5G later on, track and trace, robotics, and low power systems. So we got lots of great events coming up during the fall here at Things. Besides that, I think we're pretty much good to go. Thank you everyone for today, and I hope to see you again on our next event, which is in 3 weeks from now, Smart Transportation. Thanks a lot, everyone.
You.
You.
Cheers, bye.
Bye.